Hello everyone, my name is Anvita Bansal and we are back with our another lecture today. The problem for today is common elements. So let's have a look at the problem statement. Before that, let me check if you guys are able to see me. Let me just check if the screen. Cool. So let's have a look at the problem statement. So in the hashing section of your SDE sheet, you can see this problem common elements. Okay. So the problem is actually very easy, but you just need to understand what you have to do. You are given two lists, okay? You are given two arrays, V1 and V2. Return the list of elements common to both the lists and return the list in sorted order. You are given two arrays. You need to find what all elements are common in these two arrays and return it in an array list, and these elements should be in sorted order. That is what you need to return. Fine. So obviously it seems to be simple. It is simple, but how do we solve this simple problem? Let's understand it. So if you have V1 with these elements, let me take this test case. Let's write this test case here. Okay, so we have this with us. Fine. What elements do you see common in V1 and V2? So if we were to observe it like this and see, V1 and V2 need not to be sorted, but what you need to return should be in sorted order. So first let's check what are the common elements in these two arrays. So the common elements that we can find in these two arrays are, first if I check, I have 3 in array 1, right? I have 3. Then this 3 is found in V2 also. So in my final array list, I can have 3 once. Then I have 4 in V1. Do I have 4 in V2? No. Go to next element. I have 2 and corresponding to that I have 2 in V2 as well. Next element, another 2. I can find another 2 in V2 as well. 4. Is 4 present in V2? No. And that's the end of my array in V1. So I think if whatever elements are to be common between these two arrays, they should be found as and when I am done with the iteration of one array, right? How can you do that? So the first brute force approach can be, you compare each element of V1 of I, compare with V2 of j, whatever, let's say you are iterating V2 by index j, and if V1 of I is equal to V2 of j, you add it to your array list. Let's say you have taken an array list ARR, you add that element V1 of I to your array list, right? Okay, and if they are not equal, then you do your iteration. How do you do your iteration now? You are doing this iteration for all elements from all elements of V1, x belonging to V1, right? So you are checking if x is present or wait. That's a brute force approach. Let me write it. For I equal to 0 to what is the length of V1? V1 dot length, let's say m, okay? Inclusively m minus 1. So for all these elements, you are checking for j equal to 0, starting from 0 to n, where n is the length of V2, n equals to 4. Okay, n is the length of V1, that is 5, and m is the length of V2, that is 4. So this will become n. So don't get confused with this thing. This is just a minor thing. You will be taking care. N minus 1, and this will be m minus 1. Okay, you are comparing V1 of I with V2 of j. If both are equal, if this condition holds true, you add it to your array. Okay, and finally when you come out of your loop, you simply apply collections.sort, because you want to sort your array list. That's what you want to return. You apply the sorting algorithm to your array list and you return it. Finally return ARR. So whatever elements are common would be present in your array list in the sorted order. But this approach takes time complexity of on into m, where n is the length of array 1, m is the length of array 2. Can we optimize this approach? How can we optimize this approach? So in order to optimize this approach, we will use a brute force algorithm. We will come up with another approach that will not be this on cross m of time complexity. So how can we do it? So let me write the test case. Okay. Okay, that is your test case. So can you think of something else? First thing is, let's say if I have a hash map which stores what all elements are occurring in v1 and the frequency of all those elements. So if I were to draw a hash map or create a hash map which stores the elements of v1 and its frequency, so elements and its frequency is what they are storing. Just give me a second. Let me just come back in a moment. Yeah, okay. So what we were discussing is that let's create a hash map which will store all the elements of v1 and its corresponding frequency. You can do the same thing for the other array also. Any of the two arrays you take and create a hash map for the same. So when I come at v1, I check for the element. Does my hash map already contains it? No. So you add it, and corresponding to that you add its frequency. Then you come at 4, it's not present, you come and add its frequency. Then you come at 2, you add its frequency 1. Then you come at another 2, you will increase that count by 1, that will become 2. Then you come at 4, since 4 is already present, so you increase the count of its frequency and it will become 2. So this is your, let's say, map that stores the elements of v1 and the frequency of those elements. Now can we do one thing? Can we go and check all the elements of v2, and if any of the elements from v2 is present in your map, right, I can obviously include it into my answer array, right? And finally I can sort my answer array. Or you can do one thing, you can do this sorting thing on v2 itself, so that whatever answers you are adding in your array list, that will be in the sorted order, either of them. So I'll do both the ways, I'll explain in both the ways. This is a very minor thing in this problem, but you need to understand it. Okay, so let's start iterating over for, let's say we have already created a hash map which has stored elements of array 1, that is v1, and its frequency. Now I'm iterating over the elements in v2 and checking if my map contains those elements, right? So I will check if v2 of I is present in map, right? So let me write it properly. If your map dot contains what? v2 of I. If it contains, that means what? See, I am at 3 right now. I am at 3. I check, does map contains it? Yes, it does contain 3. So if it contains, that means, let's say this is your answer array, I can add it in my answer array, okay, but corresponding to that I have its frequency also. I need to keep count on frequency, that how many times I have seen that element in the map and have I already added into my array. So as many times I have added into my array, I'll be decreasing the frequency from the hash map. I'll tell you why and how. So if map dot contains key v2 dot I, So what you are going to do, you are going to add that answer arr dot add what v2 of I, and simultaneously you will also do one thing. Whatever frequency your map had for this element, you will decrease that frequency. So map dot put corresponding to v2 of I, whatever the answer is, map dot get v2 of I minus 1. So now the frequency of this map has become 1. Now tell me one thing, let's suppose one more 3 was there here. Then I am checking for 3 again. 3 is present in map. 3 is present in map. This condition will hold true. But should I be adding? I have already added 1 3. Let's assume that v2 is 3, 3, 2, 2, 7. I have checked for 1 3 which was present in map, and I have added into my answer array. Now I am iterating over the second element of v2. I go and check according to this condition. I will find 3 in my map, but you know that 3 was only found once in v1, and that we have already used as per our v2. So even though one more 3 is present in v2, but v1 does not contain any more 3s. That is why its frequency count has become 0. So we have to check if the frequency count, because we are updating this count also. As and when I updated this into my answer array, I know I have used 1 3 already, and because of that I will reduce the frequency of the map by 1. This is the reason this condition will hold true when you check for the second 3, but should it be added to your answer array? No, because map 1, this v1 only contains 3 only once, whereas v2 contains twice, but it only contains once. So in your answer array it should be added only once. That is why I will put one more condition, which is if map dot contains key v2 of I, also you have to check what is the frequency, and map, if that contains it, map dot get v2 of I is not equal to 0. That is the other condition that I will be checking for. Since it is 0, it will not go into this if condition, and no more value will be added corresponding to v2 of I. So I go to the next iteration. I come at this iteration. I check. Now if map contains this element 2, v2 of I is 2 right now. Map contains it, yes, and its frequency is also not 0. So I will add it to my answer, and I will reduce the frequency by 1. Now the frequency of this element has become 1. Okay, then I go to the next iteration. Now my next iteration is for 2 again. v2 is what? 2. That is present. If map dot contains key, that is true. And what is the frequency? Is it 0? No, it is not 0. That means I can include one more 2. So I have added that 2, and I have decreased the count of frequency to 0 now. Now frequency of 3 is 0, frequency of 2 is 0. Now my iteration is for the next element, that is 7. Is 7 is contained by map? No, this first condition itself is false. So I come out of this if condition. I continue with the next iteration, which is the end of array. So no more iterations, and finally what you have is this. And do you see this in sorted order? No. So finally you will sort your final answer array. Or one thing you could have done, this is one way of achieving 2 to 3. Other way of achieving 2 to 3 could have been, you can sort v2 in the beginning. Sort v2, so that the pattern in which you will be iterating over v2 will already be in sorted order. So you will be adding the values in your array list, answer array, in the sorted manner only, because sorted v2 would look something like this: 2, 2, 3, 7. Right? So when you check for each element, let's say I check for 2, initially frequency of 2 is 2, you add it into your answer array with 2. Next time you check for true 2, frequency becomes 1 and it is not 0, so you add 2 again. You come at 3, now the frequency of 2 in the map will be 0. You come at 3, initially it is 1 and it is also, it has not been evaluated before it. Now you will add 3 and make the frequency to 0. Now you come at 7, 7 is not present in your hash map, your answer will be 2 to 3. So this is another way in which you can sort your second array itself and check for the other iteration, right? So this is the way, this is one way in which using hash maps, using hash map, you can solve your problem. Okay, I hope this is clear to you all. There can be other way also without, I'll just discuss it without hash map, how you can solve. One is the brute force approach that we have already discussed. First of all, if before we move ahead, what is the time complexity of this problem? So first, initially we created a hash map for v1. We iterated over v1 in the length in on of time complexity. We iterate over it and fill up the hash map. So this is time and this is space. So we have used hash map of on of time complexity, right? And then we go and iterate over m and check if map contains any of the elements present in v2. So we also iterate over another array of m length. So basically on plus m is the total time complexity and space is on that we are using in this problem. So obviously it has been optimized from on into m to on plus m, right? Another way that I was going to tell you was 3 4 2 2 4 3 4 2 2 4, right? This is array 1, 3 2 2 7 is another array. What if I sort my arrays? It will become 2 2 3 4 4. This will become 2 2 2 3. I keep one pointer here, I keep another pointer here, right? I check both the elements are equal. When both the elements are equal, I increment the count of both the pointers by 1. And before incrementing the count in my answer array also, I will update this answer. Fine. Again, both the values are equal. For both the values equal, you will add the value only once in your array because both the elements are common. So that commonality adds to adding to that to the answer only once. Another time you add it and increment the count by 1 again. Now since both the values are not equal, which value should you increment? You see that ARR of j is less than ARR, this v2 of j is less than v1 of I at this instant. So I should increment the count of j so that maybe I get a bigger value which matches this bigger value in v1, right? That's what I do. So whenever you have a smaller value, whichever array has the smaller value, you increment the count of that pointer, increment that pointer. You getting this? When both are equal, you increment both the pointers like this. But when you have one value smaller than the other, then you increment the counter which has the smaller value. So j will be incremented and then you do the comparisons again. Both the values came out to be equal, so you add it to your answer array and then increment the count of both the indexes. One index has already come out of bounds, that is, it has iterated over the entire length of v2. That means that is the end of all the calculations. You just simply come out of the loop and return your answer. Do you need to sort this array? No, because we were already operating on the arrays before before operating on iterating on these arrays. We had already sorted these array. That is the reason we were able to use two pointer technique to iterate and collect the answers, gather the answers. So in this case we are not using any extra space. There's no extra space which is being used, right? And time complexity also remains same. So this will be a better approach anyway. But wait, here we are sorting twice, so n log n, sorting takes n log n plus m log m, that's the time complexity, and plus on of m, on plus m. So basically time complexity increases a little bit as compared to on plus m of time complexity, not bit, quite a bit, right? So this is the reason that in terms of time complexity, this is the better approach using hash map. It's just that we are not using space in two pointers technique. Here we are, but the time complexity is still less than what we are doing using two pointers. I hope the problem is clear to you. Let's go and solve this problem now. Okay, let me check if you guys are. Cool. So let's solve this problem. I take a hash map that will store the answer. Map of, it will be of type integer map new hash map, right? Then you iterate over your array 1, that is v1, and that the length of v1 is n. So let me write int n equals to v1 dot length and int m equals to v2 dot length. Fine. So I goes till n minus 1 index. You store it in the map. If map, you can use a shorthand method, map dot contains or default, that method also contains key get or default, that is what we use. Map dot contains key v1 of I. If that is true, map dot put v1 of I comma map dot get v1 of I plus 1, right? Otherwise else map dot put v1 of I comma 1. If you're finding it for the first time, then you put the frequency as 1. If you're finding for more than once, then add 1 to whatever the frequency was already present for that element. Okay, now what you do is, now let's do one thing, do arrays dot sort. Since your v2 is an array, we are using arrays dot sort function v2. Now iterate over v2 mi plus plus. On sorted array v2, we iterate over v2 and then we compare for each value if that is present in map. If v2, you can also use a shorthand way that would be much better. For int x, let's say, belonging to v2, if map dot contains key this element x, right? And another condition that I showed you was this condition. We have to ensure this condition that whenever we are reducing the frequency on adding into our answer, we are also reducing the frequency by 1. So we have to ensure that map will always contain that value if, let's say, that was present in map, but the frequency should be non-zero so that we can add it to our answer. Okay, so let me also create an array list in which we want to return our answer. It will be of type integer answer new array list. Fine. Okay, and map dot get this value is not equal to 0. If such is the case, then what you're going to do, first of all, you add this value to your answer array, ans dot add x, and map dot put x comma map dot get whatever the value was minus 1. That's what you want to update, right? So this is what we have done here, and finally when we come out of the loop, we shall return answer. Let's check. That is done. I hope the problem is clear to you. It's very simple problem, and if you are good to go with hash maps, the problem is going to be really basic. If you have any doubts, you can ask me. Let me check. Okay, let me check what all doubts you guys have. So the second approach I told you was two pointers approach, not the hash map one. And is there a difference in test case between sorting two ways? You ignore the DC of sorting. Yeah, I already discussed that time complexity of sorting will be n log n plus m log m. This is the reason the time complexity will increase when we use two pointers approach. Right. Salman is right. Correct. If you have any doubts, you can ask me in the chat. Otherwise, I think you have understood the problem well enough. So that is all about today. Hope you have all understood and I can wrap this up. I'll see you on day after tomorrow. Now. Okay, fine everyone, then that is all for today. See you all not tomorrow, day after tomorrow. Thank you everyone. Bye bye.